Testing for halide ions. So we're going to look at how we could test for the chloride, bromide and iodide ions. You probably came across this test at GCSE, but we are going to add a couple of little extra bits in. So the reagent for testing for halide ions, you may remember from GCSE, is silver nitrate, but we do need to acidify the silver nitrate. So acidified AgNO3AQ. Acidifying it, adding 1 centimetre cubed of nitric acid to the sample to remove carbonates that may give us a false positive, may produce a white precipitate. We're going to add the solution that we need to test, and because this reaction is a precipitation, we do need to use a solution, and we're going to add the nitrate, silver nitrate to our sample to get a precipitate. We are, remember, putting in nitric acid before to remove any carbonate ions. Our general equation is that we take maybe the sodium halide and we react it with silver nitrate solution to create a silver halide precipitate, AgX, solid, and then, in this case, sodium nitrate. So if we look at our ionic equation for that, which is, remember, always better for precipitation reactions, our halide ion is going to react with our silver ion to create a precipitate of a solid silver halide. And we're going to get different colours. Now, for the next part of the this couple of pages, I'm going to move forwards and backwards because I'm going to go through each of the halide ions separately, and then we will come back to the bromide ion as a separate step and the iodide ion as a separate reaction. So we're going to do each of these 3 halide ions separately. So the first one, we would place 1 centimetre cubed of anything that contained this halide ion, so it might be sodium chloride, potassium chloride, in a test tube. We're going to add some acid to remove the carbonates, and then we're going to add silver nitrate, and what we would observe is a white precipitate of silver chloride, which has the formula AgCl, and that would be our solid. That would be our precipitate. So if we just have a look at some of these questions, and remember we're going to come back to the second test a little bit later. So we added nitric acid to remove other ions that could cause precipitates. E.g. carbonate. And remember that when you add acid, the acid reacts with the carbonate ion to produce carbon dioxide and water. Could we have used hydrochloric acid? Well, hydrochloric acid, remember, is HCl. So no. HCl contains Cl minus ions, so would cause a precipitate of AgCl to form, and that would obscure any observation we were hoping to see from our sample. What would you observe if you added silver nitrate to a solution of sodium fluoride? Well, we got to go back up here and look at what it says here. F- ions do not form a precipitate with silver nitrate as it's soluble in water. So a colourless solution is seen as AgF is soluble, not a precipitate. So it asks us to do the overall equation, not the ionic equation, for what we would see when silver nitrate reacts with sodium chloride solution, aqueous. We're going to get AgCl solid, state symbol is quite important here, NaNO3AQ. If we had done an ionic equation, it would just be Ag plus Cl minus makes AgCl. I'm going to come back to question 5 when we look at the iodide ion. There is a second part to this test because it is quite difficult to tell the difference between the precipitates of the silver halides. So we can add dilute ammonia and see if it dissolves, and if it doesn't dissolve, we can add concentrated ammonia and see what difference that makes. When you do this with silver chloride, what happens is the white precipitate dissolves in dilute ammonia. So you don't actually need to add the concentrated, but if you did, the white precipitate would also dissolve because that's just more concentrated ammonia. What's happening there is your precipitate of silver chloride is reacting with the ammonia to create what's called a complex ion of silver. We get the silver ammonium ion, which looks like this and is soluble, and then you get the chloride ions as well, and they're also soluble. So your solid disappears, it dissolves. So what we're going to do now is we're going to go back and look at the test for the bromide. So if we were to do the same thing, if we put 1 centimetre cubed of the sample we want to test into a test tube, so maybe it's sodium bromide, potassium bromide, and we were to add some acid to remove the carbonates, and then we were to add silver nitrate, that what we would see is a cream precipitate, and that's of silver bromide, AgBr. And then if we were to carry on to this second part of the test, if we were to add dilute ammonia, the cream solid remains, so that precipitate that we formed does not dissolve, it's insoluble. If we were to add concentrated ammonia, the cream precipitate or solid would dissolve. So with our concentrated ammonia, AgBr just needs to have more ammonia molecules per decimeter cubed, would do the same reaction. So it just needs a higher concentration in order to get the reaction to happen. But it will dissolve in concentrated ammonia. So we can tell the difference between white and cream. If it was hard to tell, we could tell the difference by whether they are dissolving in dilute or concentrated ammonia. If it dissolves in dilute, it was the white solid of silver chloride. If it dissolves in concentrated only, it was the white solid of silver bromide, the cream solid even of silver bromide. The last one of these is to test for iodide. Again, take 1 centimetre cubed of the sample that you think contains iodide ions, add nitric acid to remove any carbonates, and then add silver nitrate, and you will see a yellow precipitate of silver iodide, which is AgI. So here we were asked to give an ionic equation with state symbols for the reaction that occurs. We're testing for the iodide ions and we're using silver nitrate. So silver is the positive ion from silver nitrate to test for the negative ion iodide. And so we're going to create the precipitate silver iodide. Positive ion, negative ion, precipitate. When you try to test their solubilities, in dilute ammonia, the yellow solid is insoluble, so it remains. And in concentrated ammonia, the yellow solid also remains. It cannot dissolve in either dilute or concentrated ammonia. The use of this ammonia is going to help us distinguish between the silver halides. It's going to be able to tell the difference because white, cream and yellow are all very similar in colour, particularly when you see these precipitates.